So I want to integrate a little bit about what we've learned about cardiac output and think about how this changes during exercise. It's something that is very physiologically important. So remember that cardiac output is equal to stroke volume times heart rate. I'm going to write that as soon as I get my mouse working again here. Oh, it's right there. Cardiac output is stroke volume times heart rate. So one way to think about how exercise affects heart rate is to first compare athletes and non-athletes. We'll then also look at change during exercise in both of these groups. So remember that we did one of these calculations already. We calculated cardiac output given a stroke volume and heart rate, something you should be able to do. So let's do that again. A stroke volume of 70 and beats per minute. So this is stroke volume, right? Here, heart rate. A non-athlete might have a cardiac output of 5,258 milliliters per minute. And that's a measure of the efficiency of the heart, how well those tissues are getting freshly oxygenated blood, removing carbon dioxide, getting glucose. It's a helpful thing to have happen. An athlete, this might look a little different, someone who's trained quite a bit, and typically the stroke volume is higher at rest. So this is at rest here, right? Like it says right there. Because the heart muscle is actually stronger. The stroke volume is due right to that contractility. It's actually larger muscle, typically stronger heart muscle. Your heart can get stronger, just like the rest of your muscles. Stronger cardiac muscle. Because of this, this individual, assuming same body size, right, same sex, biological sex, is going to have a lower heart rate. Because in order to get the same cardiac output, the heart rate doesn't have to be as high. This is actually a reason athletes have lower resting heart rates, is because the heart muscle is stronger. So therefore it beats a little bit slower. So athletes tend to have lower resting heart rates. Okay, so now what happens if these two individuals exercise? How does cardiac output change and how does it differ between these two individuals? Let's assume both people increase their heart rate to 100 beats per minute. Not super high, right? That's like not intense exercise. But what's going to happen? These individuals are going to be able to increase their heart rates to different extents. So again, we've got this formula. If we've got our non-athlete, 70 times 100, 7,000 milliliters per minute. At exercise, this is now, right? At exercise. Great. This individual now has more blood traveling to all their muscles. They can continue to exercise at this intensity, low to moderate intensity in this case. Okay, what happens to our athlete who increases to 100 beats per minute? Well, they started with a higher stroke volume, so they increase their heart rate to 100 beats per minute, and their cardiac output increases even more, right? So they're able to increase cardiac output even more than someone who is a non-athlete. So typically a non-athlete can, increase heart rate by increase cardiac output by 4 to 5 times during exercise. That's necessary to be able to get blood to your exercising tissues. Athletes often can increase more like 7 times or even more. And that's partly because of that stronger muscle tissue. So I'm going to ask you a question here. So based on this, cardiovascular system is designed to be able to increase cardiac output.